Okay, so we're going to find vertical and horizontal asymptotes and zeros for the following rational functions using the rules from the last video. So first things first, let's start with vertical asymptotes. So to find vertical asymptotes, we're looking for where the denominator is equal to 0. So we're going to set x squared minus 3x plus 28 equal to 0 and solve. Ideally right now you would pause the video and see if you can factor yourself. And if you do, we see that we have two places where the denominator is 0, when x equals 7 and when x equals negative 4. And so those, in fact, are going to be the equations for our two vertical asymptotes. Okay. And by the way, this is going to be where the domain will not be defined. Okay, for zeros, we're going to set the numerator equal to 0. Solving here by subtracting 5 and then dividing by 2, we're going to see x equals negative 5 halves is a 0. And finally, for the horizontal asymptote, we look just at the degree of the numerator compared to the degree of the denominator. In this case, the degree of the numerator is 1. The degree of the denominator is 2, so the denominator's degree is bigger, and so therefore our horizontal asymptote is at y equals 0. Now, let's graph that. And if we do, we see we have the vertical asymptote at negative 4, x equals negative 4, and at x equals 7. And we can see a 0 of negative 5 halves, right? So somewhere at like negative 2.5, we've got our 0. And finally, it's got a horizontal asymptote at y equals 0. Moving on to the next example, let's start with vertical asymptote again. So we're looking for where the denominator is equal to 0. Again, I'd recommend you pause the video now and factor that. And of course, if you can't factor it, you use quadratic formula. But this is going to lead us to our two vertical asymptotes, x equals negative half and x equals 5, because where the denominator is 0, we get vertical asymptotes. So our vertical asymptotes are going to be the equations x equals negative half and x equals 5. To get zeros, we're solving where x squared minus 5 equals 0. So adding 5 to both sides, we get x squared equals 5. So x would equal plus or minus the square root of 5. So our two zeros are positive square root of 5, 0, and negative square root of 5, 0. And finally, our horizontal asymptote, again, we're just going to look at the degree of the numerator compared to the degree of the denominator. In this case, the degree is the same. They're both 2. So the horizontal asymptote will occur at the leading coefficient of the numerator divided by the leading coefficient of the denominator. So it'll occur at y equals 1/2, 1 over 2. Again, let's graph. And we can see our graph confirms that we have a vertical asymptote at x equals negative 1/2, also one at x equals 5, a horizontal asymptote up at 1/2 for y equals 1/2, and zeros at wherever plus or minus square root of 5 would be. So that's just a little bit more than 2, positive 2 and negative 2. So back to our last example. Again, we want to find vertical asymptotes, so that's going to occur where the denominator is equal to 0. So factoring this, again, pause the video. Did you pause the video? Come on, pause the video and factor. Okay, so if you did pause it and factor, hopefully you got that the vertical asymptotes are going to occur when x equals 3 and x equals negative 2. Our zeros are going to occur where x cubed minus x equals 0. Again, we need to factor. So again, can you pause it, please? And if you factored it completely, including recognizing this difference of perfect squares, we see that we have 3 zeros. One is going to occur when x is 0, one when x is negative 1, and another one when x is, positive 1. And finally, for a horizontal asymptote, we again look at the degree and notice that the degree of the numerator is 3 and the degree of the denominator is 2. So the degree of the numerator is larger, which means that there are no horizontal asymptotes. Now, before you get too excited, if the degree of the numerator is 1 greater than the degree of the denominator, like in this case, this actually leads to an oblique or a slant asymptote, which unfortunately occurs, we can find, by doing long division. Now, before we go there, let's look at the graph of this, because we just want to confirm here that we do see a vertical asymptote at x equals negative 2, at x equals 3. We see zeros at negative 1, 0, and 1. But we also see that there's no horizontal asymptote. But in fact, we can kind of see a slant asymptote, right? So let's look at how we find that. So By the way, unless yours is different than mine, I think this is the wrong graph. So this is the right equation, but this is actually, I think, x cubed minus 3 over the denominator. So I think there's a mistake. So ignore this and look at what I just graphed on Desmos, or graph it yourself. But let's go ahead and do long division now, because we want to actually find that slant asymptote. So again, I would recommend you pause the video and see if you can set up how would you divide these polynomials. Okay, so if we divide like this, the tricky thing here that we have to keep in mind is, since we didn't have an x squared term or a constant term, we do need to hold the place by putting a 0x squared there. But from here, it's pretty routine long division. Again, I know this is no one's favorite. It's a pretty tedious process, but let's go ahead and divide. So we ask ourselves, how many times does x squared go into x cubed? It goes in x times, and we distribute that x to all three terms. So we get x squared minus, x cubed minus x squared minus 6x. And then when we subtract, that changes all of the signs. So this is going to be a positive and a positive. So we get 0 plus x squared is x squared. Negative x plus 6x is positive 5x. And then we carry down the big old 0. Ask ourselves again, how many times does x squared go into x squared? It goes in one time. So now let's change colors here. Let's do red. Oh, that is not red. Something is wrong with my pen, but that's okay. So when we multiply, we're going to get x squared minus x minus 6. And subtracting, that changes the signs. We're going to get 6x plus 6. So what is this telling us? We have a remainder here, right? But it goes in x plus 1 full times with this remainder. So in other words, r of x is equal to x plus 1 plus a remainder of 6x plus 6 out of the original denominator. So what this is saying is this polynomial behaves a lot like x plus 1 plus some remainder. Okay, so if we go back and look at the graph, right, if we tried to graph the line y equals x plus 1, so in fact, let's do that. So I'm going to delete this. If we graph the line y equals x plus 1, we see, in fact, that really does match the slant asymptote. Okay, so y equals x plus 1 is going to be that oblique asymptote. And we find that by doing long division and looking at how many full times the numerator and the denominator goes into the numerator. Okay, we're going to look at one more in this video. So again, let's sketch the graph. So we start with vertical asymptotes. Vertical asymptotes are going to happen where the denominator is equal to 0. So again, pause the video, do it yourself, guys. So we get two vertical asymptotes at -5 and at 5. X equals -5 and 5. What about zeros? Zeros occur where the numerator is equal to 0. So we have to ask ourselves, can we factor that? By the way, if we can't, we just use quadratic formula. But this one can factor. Pause the video and factor it. So we get two zeros at -0.5 and 5. And then finally, let's consider the horizontal asymptote. Looking at the degree of the numerator and the denominator, we see that they're both the same again. So we should just look at the leading coefficient of the numerator divided by the leading coefficient of the denominator. So we get y equals 2 is our horizontal asymptote. But something funny happened here, and if we graphed it, we would see it. We can't both simultaneously have a 0 at 5 and a vertical asymptote at 5, right? So I was a little bit careless when I was writing this. So we have to think more carefully. What does this mean? This is telling me that when x equals 5, so f of 5 is giving me a 0 in the numerator and a 0 in the denominator, right? So this is undefined. Remember earlier we talked about the fact that this is going to lead to a hole. So in fact, x equals 5 is not a vertical asymptote. It's not a 0. It's going to be a hole. So in fact, if we look at this graph, we see we do have a vertical asymptote at x equals -5, right? That makes sense. And we do have a horizontal asymptote at y equals 2. Again, that also makes sense. And in terms of zeros, we do have one at -1/2. But what's happening at 5? If I scroll over and try to click on 5, see, even Desmos is telling me there's a hole there. Now, you don't see it unless you're hovering over it, but we can see that when x is 5, the function is undefined.